Hello and welcome to Train Signal. You are watching Security Administration. Back during my early days as a network administrator, security wasn't the concern that it is today. Many will place the blame for most security threats right at the doorstep of the Internet. And while a significant portion of threats do emanate from the web, there are also internal risks that shouldn't be overlooked. A scan of the news headlines on any given day will detail all the things that could and do go wrong on networks that have been exploited. There are annoyances like spam that can still harbor malicious software. Then you have data breaches that could cause a loss of intellectual capital or even customer information. Talk to anyone who's had responsibility for security at their organization and you'll probably hear some interesting tales. I'll share one of my own. At one organization, I was trying to implement a corporate headquarters mandated password policy. I held a meeting explaining the new policy, part of which included periodic password changes. I talked, I explained, I answered questions, and left the meeting feeling that things had gone relatively smoothly. Only afterwards, an executive approached me, informing me they essentially wouldn't comply with the new policy because said executive felt that there was nothing of interest on their computer that should require such rigorous controls. Does this story sound familiar to you? I bet you heard some variation or another of what is an all too common theme. Now, some of these battles you'll win and some you may lose, but I'd like to think that with the media focus on security today, these occurrences are becoming less and less common. A question that plagues administrators around the world is, how do I best secure my network and systems? The answer, of course, will differ depending on your operating system. Linux has tools, techniques, and best practices to help secure your servers and hosts. So in this lesson, we'll talk about the Linux Super Server, a tool used to help provide another layer of insulation and protection for your network. We'll move on to unused servers that may be running on your network and the security risks they pose. Then we'll talk about configuration files and how they can be used to track down unnecessary servers. We'll close things out with a look at security for the computers or hosts on your network. Let's start off with the Super Server on the next slide. Before we talk about the Super Server, let's take a moment to talk about security in general. This is arguably one of the most important job duties of a network administrator. Sure, you may have to install, configure, and manage systems and servers. You might also perform software and hardware upgrades. And of course, you have to troubleshoot and solve network issues. But the underlying issue, the concept that you must think about at each layer of your network, is security. And this is a subject that Linux Plus takes seriously. A concept that I learned early on about security was called defense in depth. This is another way of saying that you should have a multi-layered approach to security. There are the simple things at what could be a first layer, things like physical access control. That's making sure that your data center or server rooms are secure, or giving mobile employees locks for their laptops. At the next layer could be firewalls or other security hardware technologies. Then there's patches. As you know, many exploits occur from known software vulnerabilities, so ensuring that you have the most updated software helps to minimize this threat. You should also have a plan for permissions and resource access rights. For instance, developing a password policy like we just discussed. And you should also take a proactive approach to security monitoring. Read up on the latest security threats and use the best tools to help monitor your network traffic. Okay, now let's move on to talk about the Super Server. Typically, network server programs open a port when the system boots up and listens for a connection. But some programs have a go-between. That go-between is called the Super Server. This program listens for network connections on behalf of another program and then hands off control to the intended server. This scenario has a couple really important benefits. First off, it reduces memory. When a request for a network service comes through the Super Server, it processes the request, starts the daemon for the requested service, and forwards the request on to that server. Once that request is completed, and the network service isn't needed any longer, the Super Server unloads the daemon from memory. The other benefit is the security one. The Super Server can add security checks that apply to all servers that it manages. Typical examples of network services managed by the superserver might include SMTP or POP3. The two types of superservers are inetd and xinetd. Let's take a look at inetd on the next slide. inetd used to be the default superserver and may in fact still be on your system, but many distributions have turned to the inherently more secure xinetd, which we'll discuss in just a moment. To see if inetd is on your system, you can use the grep command that we've used a few times already. The syntax is ps space ax space pipe space grep space inetd. So the next question is, how do you add servers to inetd? You do so through its configuration file, which you've probably guessed is stored in the etc directory. The name of the file is inetd.conf. The format for this file has one line for each server with the following fields. The first is service name, and that's the service name as it appears in the etc services directory. Next we have socket type, which is the type of connection, and that could be stream, dgram, or raw. The next field is protocol, which is either TCP or UDP. Then we have wait, no wait, which for dgram sets whether the server connects to its clients and frees the socket, that's the no wait option, or processes all packets and then times out, that's the wait option. You use the no wait option by default for other socket types. Our inetd file fields continue with user, which is the username used to run the server, and that's usually either root or nobody. Then we have the server name, which is the actual file name of the server. And finally we have parameters, which is essentially everything after the server name. This is where you may indicate the full path to the true target server. And as you know, hash marks denote comments. If you'd like to activate a line that's in your configuration file, you simply remove the hash mark to do so. And as you know, if you make changes to the file, you'll need to restart with something like etc rc.d, init.d, followed by inetd space restart or either reload. But instead of using the startup scripts, you can also use the kill or kill all commands. These commands, if you recall from our run levels and system shutdown and reboot lesson, send the SIGUP signal. The syntax is kill space dash HUP in all capitals, followed by the process ID, or either kill all space dash HUP, followed by inetd. Security wasn't built into inetd, but can be implemented using the TCP wrappers program TCPD. The way that it works is inetd will call TCPD, which checks to see if a client is indeed authorized to access the specified server. And if it is, TCP, and not inetd, will call the server program. You configure the settings for TCP wrappers with the etc hosts.allow and hosts.deny files. Allow, of course, lists systems allowed to access the server, and deny will list computers not allowed access. If for some reason a computer ends up being listed in both files, the allow file always takes precedence. The format for entries in these files is daemon list space colon space client list, where daemon list is the list of servers as they appear in etc services, and client is a list of computers either by IP or name or network with the leading or trailing dot. Let's open a terminal window and see first if we're using inetd, and if we are, we'll take a look at the associated file. Let's open a terminal window, Applications, System Tools, Terminal. Now remember the command? Okay, let's type it in. ps space ax space pipe space grep space inetd, and hit enter. And inetd is indeed installed. Now let's see if we have the configuration file. Let's type in cat space etc inetd.conf and hit enter. And we see that that file doesn't exist, which means that we haven't set up any server programs that should be managed by our super server. So using the format that we just learned, let's go ahead and create one. First, let's obtain root privileges with SU for switch user and enter your password. Now we'll type in vi because we're going to use the vi text editor, and we'll enter the path for the configuration file, which is etc inetd.conf, and hit enter. We'll hit I to go into insert mode, and I'm going to start off our file with a comment, and I'm just going to include demo for the inetd file, and hit enter. Now say we wanted to add the FTP server. We type in FTP, going to use stream for the socket type, going to use TCP for the protocol, and I'm going to enter no wait here, since if you recall, this should be the default if the socket type is not dgram. And again, no wait sets to process all packets and then free the socket. I'm going to run the command as root, and we're going to place a call here to TCPD for TCP wrappers. And the location, let's just say it's user sbin TCPD. And then we're going to end it with a parameter that's going to name our target server. And that again will be user bin, and let's say it's FTP. And say we were done. We would go ahead and hit escape, enter the command :WQ to save and quit. And then from this point, if we actually wanted to enact the change, we will restart the server either with the command that we just looked at, which is etcrc.d, inet.d, inetd restart, or again you could use the kill all command, or kill. But we don't want to do that, so we will go ahead here and just remove the file that we created. So we'll type in rm, which is delete, and we're going to go ahead and delete the file, inetd.conf, and hit enter. I'm going to say yes to confirm. And now let's hop over to our Ubuntu test system and see if inetd is running on that system as well. Again, you could either have inetd or xinetd or both. Okay, from our Ubuntu test system, let's go ahead and open a terminal from Applications, Accessories, and Terminal. And from here, let's just use the grep command again to see which server we're running. Type in ps space ax space pipe space grep, and let's try inetd and hit enter. Okay, and we see inetd is indeed running on this system as well. So for Ubuntu and for Fedora, inetd is still installed. Now your system may be a little bit different. Okay, let's head back to the presentation and talk about the other super server next, xinetd. As we've talked about before, things change in Linux from release to release. You have updates, you have new programs, and enhancements and the like. So it should come as no surprise that inetd was superseded by the new kid on the block, xinetd. This extended super server, which includes TCP wrapper functionality built in, has become the new standard. As we discovered, our Fedora system had inetd installed, and in a moment we'll take a look and see if xinetd is installed as well. The configuration file is etc xinetd.conf, and of course, if you make changes again, you'll need to restart the daemon. The options for xinetd include bind, which says to listen on only one network interface. Then you have only from, which is used to specify IP addresses, network, or host names separated by spaces. Then you have no access, which contains a blacklisted computer list or networks. And then we have access times, which sets times during which users can access the server, in the format hours, minutes, -hour, minutes. Let's go back to the terminal and see if we have xinetd on Fedora. First, let's search for inetd. I'm going to type in ps space ax space pipe space grep space xinetd and hit enter. And we do indeed have that installed as well. Now let's search for a configuration file. Let's type in cat space etc xinetd.conf. Now that file doesn't exist, but we know that on Fedora, some configuration files are stored in a different directory. So let's take a look at the xinetd.d directory. So let's type in ls space etc xinetd.d and hit enter. And we have one file, which is rsync. Let's take a look at the contents of that configuration file. So let's type in cat space etc xinetd.d rsync. And again, on Fedora, instead of everything being stored in one configuration file, it's more common to have different and individual configuration files for each server. So if we had an FTP server, we'd have an FTP file here. If we had a CUPS server that we wanted to manage with xinetd, we'd have a CUPS file here as well. So let's go ahead and hit enter. And again, we have some comments, description of the server. Then we open with the line service and names the service. Got some flags, tells you the IP version, the socket type. Instead of no wait, we have the wait parameter here, and we have no on the other side. We've got the user, the server name, followed by any arguments. And also logon failure parameters set here as well. Now let's go back to the presentation and talk about unused servers. While perusing your configuration files, you may run into a server that you're not quite sure if you need. Best practices suggest you disable unused servers as they could pose a potential security risk. But most of the time, you won't look to your configuration files to find unused or unneeded servers. Not when Linux has tools to help do the job a lot easier. The first of these tools is netstat. Now this is the network status tool that we first covered in our network configuration and troubleshooting lesson. And if you recall, used with the -AP option, netstat will list all open ports or network connections. And these again are those outlined in etc services. Another tool is LSOF, or LSOF. This tool tells you what files are open in a directory, as well as other information like who's accessing the file, for example. And file doesn't mean file in the traditional sense. This also includes network connections, a very important distinction. To use LSOF, you have to add the -I option. You can also look for a specific port by including a colon followed by the port number. Then we have Nmap, which is a network scanner. Now another popular network scanner that you might be more familiar with is Nessus. Nessus has the same functionality, but also checks for known vulnerabilities. Nmap scans for open ports on local and other computers. Use the option -s T to scan for TCP ports and s U to scan for UDP ports. So a typical command might read nmap space -s T space checkthishost.com. Let's go back to our terminal window and try these out. First, I'm going to clear our window with clear. Now to look for all open ports, let's type in netstat, and you should still have root privileges, by the way. Let's type in netstat space -AP and hit enter. Let's scroll back up to the top, and you may also want to expand the size of your window for this output. Now the important columns here are where you see stream, which of course is the socket type. This column lists connected, and this tells you whether or not the service is connected, or you might see listen here. Then you have the port number and the name of the server. And the first one you see here is Evolution, which is the mail client. And if you look, you've got Nautilus, you've got Pulse Audio, and some others. Now let's say we wanted to narrow the search a little bit. We type in netstat space -AP, and we're going to use the grep command to search. So we're going to add in a pipe, then we're going to type in grep, and let's say SQL, and hit enter. And since it didn't find anything, we know that SQL doesn't have an open port currently. Now let's try LSOF. So let's type in LSOF, and again we have to have the -I option, and hit enter. And in the results we see the name of the server or the command here. We've got DH client, we've got cups and some others. Then we've got process ID, we've got the user that's actually running the program. Then we've got the next important one is type, and then we have node and name. Now again, if we wanted to restrict our output here, we could include a port number. So let's try that. Let's type in LSOF space -I, and we're going to do a colon, and we're going to try port 25 and hit enter. And it came back and told us that we've got send mail here, which is for this specific port. And as for an Nmap, I say proceed with caution. These types of scanners are used by hackers to try to locate network vulnerabilities. And they do so by looking for, of course, open ports. And some organizations may not be too keen on you running this command without prior authorization. So before you test out this command, make sure that you either have permission to do so, or that you do it in a controlled test environment. Of course, that may not yield very much information, as in our own test systems, but in this instance, it's better to proceed with caution. Okay, so let's head back to our presentation and talk a bit more about configuration files in general. As we've learned throughout all our lessons, programs will have configuration files. So in theory, you could spot unwanted servers by taking a look at your configuration files. Now there are two types of scripts that you should be concerned with. The first, as you already know, are sysv startup scripts. And they exist in directories like etc rc?.d or etc init.d rc?.d or even etc rc.d rc?.d. And the question mark again refers to the default run level. And we've just learned about super server scripts, which unlike sysv startup scripts are only used to launch network servers. You may also want to check out your etc init tab file, which on some systems started processes used to accept text mode logins or dial-up connections. These processes might be called getty or min-getty. Most modern systems have moved these functions to other files though, typically places like etc event.d. So most of the time you probably won't need to modify these. After you've identified servers using your configuration files, or more likely your network scanning tools, you'll be tempted to want to disable a bunch of servers. Before you do that, I'd recommend that you spend some time researching anything that you don't recognize. You do this so that you don't accidentally disable something that you really need. But chances are you will need to make some changes. And to do that, you've got two options. You can either disable the server via startup script or super server script. With this option, you can easily reactivate the server if you do find that you might need it. Your other option is to remove it completely via the package manager like Yum or apt or aptitude on Debian systems. This will reduce the chances that an unwanted server accidentally springs back to life, opening up a security risk. But of course, with this option, it won't be quite so easy to get it back. Still, if you're sure you don't need the server, removing it completely is the preferred choice. Now that we have our server secured, let's move on and talk about host security. Everything we've talked about up to this point largely involves server or network security. But we can't forget about our host security. Each of these systems represents a potential attacker entry point to your network. So we must put just as much energy into securing these systems. One of the easiest things you can do to improve host security is through the use of secure passwords. This is an area where you'll have to set the rules, put faith in your users, and then check up on them periodically to make sure the rules are being enforced. At Global Mantix, one of the first things the new CIO wants to do is to revamp the company's security policy. And as luck would have it, he's a stickler for one of the most obvious but most abused security measures, using strong passwords. What exactly constitutes a strong password? Well, for starters, it shouldn't contain dictionary words or regular, easily recognizable phrases. Also off limits, names or places. A strong password should include numbers, punctuation marks, a mix of upper and lowercase letters. You get the idea, and you can be very creative here. And also, it's configured by default, but you should also use shadow passwords. We talked about these in the user and group accounts lesson. And as no password is totally uncrackable, you should force periodic password changes. And I always say the best defense is to educate your users. Make sure that they know that they should use different passwords for different systems. Tell them about social engineering and phishing, and how an infiltration on their computer could affect the entire network. In addition, if you need remote logins, be sure to use SSH instead of Telnet or FTP if you can avoid it. And another measure that you can take as an administrator is to run password cracking tools on your network to gauge password strength. Again, this is one of those tools used by folks intending to do harm to your network, so just make sure that your organization is aware of the tools that you're using before you start using them. Now let's go back to the terminal for just a moment. Okay, I've cleared our terminal window, and we're going to try to create a user. You should still have root privileges, so we're going to type in user add Linda and hit enter. Looks like we already have a user Linda, so let's try another one. Let's type in user add space Jane and hit enter. And the user should be created. Now let's type in PASSWD to create a password for Jane and hit enter. Now we enter the new password, and I'm just going to enter Jane. You see that error? It says that we have a bad password. It's too short and it's too simple. This is Linux giving you a helping hand, just alerting you that you should use a more secure password. I'm going to Control C to exit out of here. Now remember the option associated with user add that sets the account to expire? That option is -E. And again, this is useful for if you have a user that you know will only be at the company for a short period of time. So let's try that option. Let's type in user add space -E. Then we need to enter the date in the format year, month, and date. And we have 4 spaces for year. So we'll put in 2010-12 for the month and -30 for the day. We need to put in a user. Let's call the user Johnny and hit enter. And that created the user, and in just a minute we'll learn how to check the settings for each of these user accounts. In addition to password and account expiration settings, another host security option is to set limits on what your users can do, like logging in and how much CPU or memory they can use. This is done through pluggable authentication modules or PAM modules called PAM limits. The idea is to limit the amount of damage that can be done to the network through more strict controls. By imposing limits, you make it impossible for one user to consume enough system resources to slow or cripple a server or program. You edit the file limits.conf, which is stored in etc security, in order to configure PAM. The lines in this file have 4 fields. The first is domain, which is the entity to which the limit applies. Then you have type, which specifies hard or soft limit. Then you've got item, which is the type of item being limited. And the last one is value, which is the value of the limit. Let's go back to our terminal and take a quick look at this file. Let's go ahead and clear the window. Now let's type in cat etc security limits.conf and hit enter. Let's scroll up. At the top here we've got some comments, and it tells us about the domain and the type and the item and the value. And we have a few samples here. For instance, we have a group, which you recognize with the @ sign, a group called student that has a hard limit on this item in proc, and the value is 20. The asterisk that you see here means everybody. So this line says that everybody has a soft limit for the core item process, and the value is 0. Now at Global Mantics, we have a developers group, and they may need a little more CPU and memory time than other users. So let's edit this file and add an entry for them. Let's type in vi space etc security limits.conf, vi etc security limits.conf, and hit enter. And we're going to hit I, and let's go down to the bottom. We could theoretically add a line here that said at developers, which would be the name of the group. Well, let's make it a hard limit for CPU, which would be 5. So 5 would limit their CPU usage so that users can use programs, but if one consumes more than 5 minutes of CPU time, it would terminate. Now, if you wanted to, if this was a real group and a real limit that you wanted to set, you could save the file here and exit, but we don't want to do that, so we'll just hit escape. We'll hit colon, then we'll hit Q and an exclamation point, which will exit the file without saving. We first learned of the chage command in our user and group accounts lesson. This tool can be used to force password changes at the interval you set, and also disable an account after a specified period of time. You can also use usermod, which can make changes to an existing account using many of the same parameters as useradd, but the preferred option is chage. Throughout our lessons, we've used the su or switch user command to obtain root privileges. And as you know, root is all-powerful, so you want to limit its use, mainly because if you log in as root, no record of who typed in the password will show up in the log files, and that root password could be intercepted. So instead of logging in as root, you use the su command to obtain root privileges temporarily. If you type in a username after su, you acquire that user's privileges. And of course, if you do this as root, no password is required. To run a single program as root, you use the su space -c option. Or for instance, su space -c and netstat in quotes. Sudo is used to run a single command as root. For example, you could type in sudo space netstat space -ap. You set up who has access to sudo by editing the file etc sudo ers. And you do this not with the regular vi editor, but with an alternative vi sudo. This file has two entries, aliases and user specs. Aliases are variables, and specs link users to machines and commands. Let's take another look at the command chage. Okay, I've cleared our window, and let's try the command out. Let's type in chage space -m, which is going to set the minimum days between password changes. We'll set that for 60. Then we'll do an uppercase M, which sets the maximum days between changes. We'll set that for 75. Then we'll do a -I, which will set the inactive days or days between password expiration and account disablement. Set that to 5. Then do a -E, uppercase E, followed by the date, which we'll set to 2011, 01 for the month, and 31 for the day. We'll make this change to the user Nancy and hit enter. Now let's take a look at the listings for Nancy's account by typing in CHAGE space -L space Nancy. And we see that we have our account expiration date set. We've got the minimum number of days, the maximum number, and we got warning days. These are defaults. Things that we don't specify with the command, we'll take the defaults. Okay, let's head back to the presentation and talk about uLimit. Nothing irritates network users more than slow or sluggish network response. And we now know how to use PAM to set user and group resource limits to limit this possibility. But there's another command that we can use to set limits for the shell environment. That command is uLimit. And again, this command will only affect bash and any programs you launch from bash. The command syntax is uLimit space options followed by the limit. And you can use the -A option to show your current settings. Additional options include C, which limits the size of core dumps, and you've got F, which limits the size of files created by the shell. N limits the number of open file descriptors. U limits the number of processes a user can run. T limits the CPU time in seconds. And V sets virtual memory available to the shell. Our uLimit options continue with -S, which sets the maximum stack size. Then we have D, which limits the program dataset size, and L sets the maximum size that can be locked into memory. -H and -S make the other options hard or soft limits. Now, switching topics, in many network environments there are probably one or more dedicated servers sitting around that don't have users other than root that need to log in. These systems are good candidates for the etc no login file. If this file is in the etc directory, only root can log into the system. Other users are just shown the contents of this file if they try to log in. Let's head back to the terminal and try out the uLimit command. Let's go ahead and clear the terminal with clear. Now let's type in uLimit -T space 50. And again, -T is going to set the limit for the CPU time in seconds. And hit enter. Now let's type in uLimit -A, which will show all the settings. And you can see our CPU time setting here for 50. And again, this is for bash or programs that you launch from bash only. In our lesson on managing user resources with quotas and file permissions, we first learned about the SUID and SGID files. These files have settings which tell the system to run the associated program as the file or group owner. But setting a program to run as root poses a security risk. Just think of setting the rm command's SUID as this is a program that's owned by root. If you did so, any user would have the potential to delete the entire directory tree, instead of only the files that they own. So it's best to search for any SUID and SGID files periodically. To do this, use the find command with the option -PERM, and you specify permissions of 6,000, which covers SUID, which if you recall is 4,000, and SGID was 2,000. So the command would read find space / space -PERM space +6000 space -type space F. And again, if you recall, the F option says to search for regular files. You could then modify anything that seems out of order. And that concludes our lesson on security administration. Let's review what we've learned on the next slide. This lesson covered an important subject that spans a variety of topics. In truth, security threats, mitigation techniques, and even the tools seem to change on a weekly, if not a daily basis. This is one of those aspects of network administrators' jobs that can be exciting if you're up for the challenge. In this lesson, we began with a general overview of security and moved into a discussion about the Linux superserver and how it acts as an intermediary between programs and clients. And controlled by the etc hosts, allow, and deny files provides an extra layer of server security. Then we talked about unused servers and their potential security risk. We learned that while best practices dictate that unused servers should be removed, you should only do so after thoroughly investigating whether or not that server is really needed. We also took a look at configuration files and how they can be used to also identify unused or unneeded servers. We wrapped up with a look at host security, including password rules, resource limits, and another look at permissions. Thanks for watching, and I'll see you in the next lesson.